Hello everyone, I'm Jeevan Raj, a certified data science and analytics coach working at Imaticus Learning. Today I will be helping you to understand what is statistics and how the statistics is very useful in terms of machine learning and what are the various types of statistical methods that you can use, what is descriptive statistics, inferential statistics, and what is population and sample. So we'll be discussing all these factors in this today's session. So without further ado, let's begin with today's agenda. So in this session, you will be understanding in detail of what is descriptive statistics and inferential statistics. In the descriptive statistics, what is measure of central tendency, what is mean, median, mode, standard deviation, variance, quartiles, etc. And also you will be understanding what is measure of dispersion. So the measure of dispersion comes where the variance, and we'll also be learning what is skewness and kurtosis, and then we'll also learning what is covariance and correlation. So why we use statistics, right? Why we want to use statistics in terms of data science? So always while you're learning any of the language or any of the tools, always you want to ask one question, that is why you want to learn and what exactly it is and where can be used for. So if you ask me like why we want to learn statistics, statistics is very important in terms of making investment, prediction and making some decisions. It can be very powerful tool when performing the data science tasks. So it is used to solve the complex real-time problem. So we'll begin with what exactly statistics is all about. Statistics is a branch of science which deals with the data collection, analysis, interpretation and presentation of your data. One can drive the meaningful insights and trends in the data by applying various statistical methods on it. For an example, if I give the data to you, you can start applying various statistical methods such that you can see what is the minimum sales that was generated throughout the year, what is the maximum sales or what is the average sales that were generated over the year. And by using the statistical methods, you can also understand whether the data having an outlier or not. We'll be talking in detail what is outliers and how will you calculate the outliers. Now we'll talk about what are the types of analysis that we have. Majorly, we have two different types of analysis. One is descriptive analysis and the other one is inferential analysis. Descriptive analysis is used to describe the sample and summarize the insights about the sample, where you are working with the sample set of records and you are going to describe those sample is called descriptive analytics. Whereas in the other hand, we have inferential analysis. It is used to make conclusion and generalization about the population, where it is used to make the conclusion and the generalization of the entire population. In the descriptive statistics, we have measure of central tendency, measure of dispersion, etc. And in the inferential statistics, where we have linear regression analysis and analysis of variance and confidence interval. We'll be talking detailed of what is measure of central tendency. In the measure of central tendency itself, we have various different types. So we'll be talking each and every types like what is mean, median and mode, variance, etc. So now we'll talk about what is population and sample. So population is nothing but a set of all the observation or set of all the objects or individuals considered for a study. It may be finite or infinite set of elements. That is what population is. Samples are nothing but the subset of the entire population. For an example, if you want to do some analysis, we cannot take the entire population to make a survey, right? So there may be chances some of them are newly born or some of them may die. So at that particular case, we take the sample from the entire population and we start making an analysis. For an example, another example you can take, if I go to the interview, whether the interviewer will ask all the questions to me which is in the topic? No, it is impossible to ask all the questions related to particular job role. So what he does, it takes only the sample set of majorly asked questions and he will ask to me. If I am able to answer, that means that I have a good knowledge on the particular topic. If I am unable to answer, based on the sample, he will make me that prediction that he is unable to explain the sample set of information and it will start concluding to the entire population. So now we'll talk about what is descriptive statistics. Descriptive statistics is nothing but it contains the information, or it consists of the analysis that can be used to understand the data from various visualization and numerical techniques. It also helps to study the underlying patterns in the data. It is a type of analysis. It's only used to understand the data set under the study of samples and generalization to the entire population. The descriptive statistics majorly consists of measure of central tendency, measure of dispersion, skewness, kurtosis, and as well as covariance and correlation. What is measure of central tendency? The measure of central tendency means the central position of the data that can be distinguished between the measure of central tendency. That means if you want to divide the data into two halves, so we go for measure of central tendency where your mean, median, mode will lies between the center position. So there are different measures of central tendency, like I said, mean, median, mode, and quantiles. Mean is nothing but the average of all the observation. Median is nothing but if we sort the data in ascending or descending order, the middlemost observation we call it as median. Mode is nothing but the most frequently occurred values is called mode. Quantiles is nothing but it divides the data set into n equal parts. Now we'll talk about mean. As I mentioned, it is one of the measure of central tendency where it is mostly used to measure the average of the data. It defines the sum of all the observation divided by total number of observation. That is what mean is all about. The advantages and disadvantages of using the mean for filling the null values are, it is based out of all the observation, it takes use of all the observation, but the disadvantages is if there is an outlier that is present in the data where the average will vary. So we want to treat the outliers if you are going to use mean. So it is a best practice to use mean if the data set is not having an outlier, and if you cannot use mean if the data is categorical in nature. So this is some example that we have mentioned here. So later on stages we'll start performing various examples how to calculate mean for this set of list of elements. So now we'll talk about median. What is median? Median is nothing but the middlemost observation in the data set. So if you sort the data in ascending order or the descending order, so the middlemost observation we call it as median. Consider if the data is in the odd position, so at that particular time your middlemost observation is your median. If the data set is in equal parts, that is nothing but if it is an even observation, so at that particular times if you want to take two middlemost observation and take the average out of it. So the advantages and disadvantages of median is, the advantages where it is not affected by the outliers, but the disadvantages is where it is not based out of all the observation. Now we'll talk about mode. What is mode? Mode is nothing but the more frequent value or the highest frequency of the observation, more occurrence of the values, that is called mode. So the data can have one mode or it can have multiple mode. So if the data has only one mode, we call it as unimodal. If a group of observation with two modes is called as bimodal. So if the group of observations with more than two modes is called as multimodal. So the advantages and disadvantages here is, it is affected by the presence of outliers, where mode is not affected. As I mentioned, the mode does not affected by the outliers, and it can be calculated for numerical and as well as for the categorical data. But the disadvantages is, as I mentioned, it is not used for all the observation, right? It is not been considered by all the observation. So here we have given the example for the mode. So it is nothing but most frequently observed values. What is quantile? Quantiles are nothing but These are the values that divides the dataset into equal number of halves or parts. Quantiles are also called as partition values. These values may be equispaced, where median divides the dataset into 2 equal halves, quartile divides the dataset into 4 equal parts, decile divides the dataset into 10 equal parts, and percentile divides the dataset into 100 equal parts. Now we'll talk in detail of what is quantiles. Quartiles divides the dataset into 4 equal parts, as I mentioned. Where first quartile we mentioned that it divides the dataset into 2 equal parts. One is 25% and 75%. We can easily state that if we have one quartile or the first quartile that divides the data in such a way that 25% of the data below Q1 and 75% of the data is above Q1. If you want to talk about the second quartile, that means it is also called as median, that divides the data into 2 equal halves. So now we'll talk about third quartiles. So that divides the data in such a way that the 75% of the data is less than Q3 and 25% of the information is above Q3. Whenever you are dealing with government exams or any CAT or any exam, what you can do, they can take the quartiles rather than taking the percentile. Now we'll talk about decile. Decile divides the data into 10 equal halves. So the first decile divides the data in such a way that the 10% of the data is below D1 and 90% of the data is above D1. So if you want to talk about fifth decile, that means it divides the data into equal halves, that is nothing but median. Percentile is nothing but it divides the data set into 100 equal halves. So if you want to talk about first percentile, that means it divides the data in such a way that 1% of the data below P1 and 99% of the data which is above P1. So if you want to talk about 25th percentile, that means the data is divided in such a way that 25% of the data is less than P25 and 75% of the data is more than P25. You can also tell that P25, that is nothing but first percentile, 25th percentile is also called as Q1, first quartile. Now if we talk about 50th percentile, that means it divides the data set into 2 equal halves, where it is also called as median or it is also called as second quartile. So if I want to talk about 75th percentile, that means 75% of the data which is less than P75 and 25% of the data is more than P75. That is also called as Q3, third quartile. So now we'll talk about measure of dispersion. So the measure of dispersion is nothing but it is a technique that summarizes the variation in the data points. If the dispersion is less for the set of observation, then the reliability of the data measures as high. If the dispersion is more, that means the reliability is very less. So the range, variance, standard deviation, and these are the measure of dispersions. Now we'll talk about range. Range is the first parameter for measure of dispersion. So it is defined as the difference between the largest and as well as the smallest observation. Range varies between minimum to maximum values, where xn minus xn to x1, that means where x1 is the largest values and x1 is the smallest values in the dataset. It depends only on two extreme observations in the data points, so it does not provide proper idea about the variations in the data points. Now we'll talk about what is variance. Variance, it measures the spread of observations from the mean. It is defined as the arithmetic mean of squares of deviation calculated from the mean. It is given by the formula, that is xi minus x bar whole divided by n. So we'll try to use what is variance and as well as standard deviation in practical use cases. So let me go to practical stuff and start explaining how to use all this descriptive statistics. So let me open my Jupyter notebook. So let me write it as descriptive analysis. So in this descriptive analysis, let me add few more parameters, that is mean, median, mode and quantile. So as we discussed, mean is nothing but the average of all the data points. Median is nothing but the middlemost observation when the data is divided into ordered into ascending or descending order. Mode is most frequently repeated observation. Quantiles divides the data set into n number of parts. So let me define some random list of elements here. So LIS is equals to P dot, let me convert it into series format. So list of elements, that is 2, 3, 4, 2, 1, 4, 12, 11, 10, 9, 8. So let me execute this. So PD is not defined, so let me import the pandas. Import pandas as PD and import numpy as NP. So let me import the necessary libraries and run this. So it is successfully executed. So if you want to print the mean, that let me write as lis dot mean. So the average of this list of elements is 6. So how it is calculated? That is nothing but sum of all the observation divided by total number of observation. So sum of list divided by total number of observation. So length of list. So this is your mean value. So now we'll try to perform box plot to check the outliers. Let me import a C1 here. Import C1 as SNS. So let me specify C1 SNS dot box plot and let me provide the list of information. So let me write X is equals to list of elements. So you can see the data is not having any outliers, so it is not highly affected. So what if the data is having an outliers? Let me copy it or let me modify the same list. Let me provide some 199. So 199 is having an extreme and right. So it is completely different from the actual representation of the data. So if you execute the other query, can you see here the mean is highly varied from 6 to 22, right? So you can see here the mean is highly varied from 6 to 22. So if there is only one outliers, it will affect drastically. So you want to make sure that the data that does not contains any outliers while performing the mean. Now we'll talk about median. What is median? Median is nothing but the midmost observation once the data is sorted in ascending or descending order. So now let me print the median. So that is nothing but list dot median. So you got the output as 6. So that means length of list. So totally we have total length of list is 12. So if I want to take the middlemost observation, how do I take the middlemost observation? First I want to sort the data in ascending or descending order. Let me sort the information sorted of list. So the data is sorted in ascending order. Now if I want to take the middlemost observation, that is nothing but total number of elements that is present inside the list is 12 divided by 2, that is 6. So this is your 0th index position, 1st, 2nd, 3rd, 4th, 5th and 6th index position. So here you can see the data is having what equal number of observations. So what it do, when the data is in even position, it will take 2 middlemost observation and divided by 2. That is nothing but it calculates 4 plus 8 and the resultant is 12 divided by 2. So that's what it does while performing the median. So let me provide the index position as 5, that is 4, and index position of 6 is 8 divided by 2. Index position of 5 and index position of same thing, let me copy it. Index position of how much? Index position of 6. So totally we get 12. So we will divide by 2. So they will get the median. So now we have calculated the median. Now we'll calculate the mode for it. So let me write as list. What is the variable name? The variable name is list dot mode. So mode will provide you the most occurrence values. So if the information is present at one time, that means that is unimodal. So you can see 2 and 4 is repeated multiple times. So 2 is repeated once, 2 times, and as well as 4 is also repeated 2 times. So it is printing it as bimodal. It is printing 2 information. So for an example, consider 2 is repeated again. That means the mode will be, output will be 2. So this is basic of descriptive statistics, what I can say. So now we'll talk about the quantiles. Quartiles. So quartiles is nothing but it divides the data into 4 equal halves. So this is your list. So this quartiles will divide the data set into 4 equal halves. You can just write as list dot quantile of 0.25. That means it divides the data set into 25th percentile. So the 25th percentile of the data is 2, and if you want to check for the 75th percentile, you can do the same thing. You can just write as print of this information, that is 2, and print rather than 2.5, that is nothing but you can just write as 5. That means it is printing the 50th percentile. Print rather than telling 5, you can just specify the 7.5. That means 75th percentile, 0.75. So the 50th percentile is 4, that is median, and as well as this is your 25th percentile and this is your 75th percentile. What is this 10, 2 and 4? That means you can say that 25th percentile is 2 is nothing but where 25% of the students who have scored less than 2 marks. Consider the less is nothing but the marks of the students, and 5 is nothing but 50% is nothing but 50% of the students who have scored less than 4, less than or equal to 4, and 50% of the students who have scored more than 4. So 75th percentile or 75th percentile is nothing but, or third quartile is nothing but 75% of the students who have scored less than 10 marks and 25% of the students who have scored more than 10 marks. That is what 75th percentile, that is third quartile is all about. So now we'll talk about decile. Decile divides the data set into 10 equal halves. So decile. So print first decile. So list dot quantile of 0.10. So that will print the first decile. If you want to print the 50th decile, that is nothing but 50th decile is nothing but median. That is nothing but second quartile. So second quartile is nothing but it is printed as 40. Same thing is mentioned here as well, decile. So now we'll go for percentile. percentile divides the data set into 100 equal halves. So if you want to print the first percentile, you can just specify it as print, and you can write it as first percentile and you can specify the less dot quantile of 0.01. So this is your first percentile. So that divides the data set into 100 equal parts. So we can also perform some of the statistical techniques or statistical informations. Statistical techniques. So what are the statistical techniques can be used? One is total. That is nothing but sum. Next we can also find the mean, average. Then we have median. Then we have fourth one, we have mode. And we have maximum values and minimum values, range of values, standard deviation, and lastly we have variance. So these are the different statistical techniques that can be used. So to find the total, you can specify list dot sum, so that provides the total. If you want to perform mean, you can just specify list dot mean. So if you want to find the median, you can just write as list dot median. So if you want to specify mode, if you want to extract the mode, so you can just specify list dot mode. And if you want to extract a range of values, you can do that by specifying range is nothing but less dot maximum value minus less of minimum value. So this is the range of values. List dot minimum values, right? So this is the range of values. So we can also take maximum values, that is nothing but list dot max will print the maximum value. And to extract the minimum value, you can just write as list dot minimum. And if you want to find the standard deviation, you can do it. To find the standard deviation, is nothing but like it helps you to understand how much it is deviated from the mean. So to perform it, you can just write it down. You can first define the data here is equals to. So you can write as for in sorted of less. First you are sorting the list of elements. Next you are providing data dot append, that is I minus list dot mean into 2. So here you can just write as np dot square root of sum of data divided by length of less. So I'll get the standard deviation. It is telling how much it is deviated from the mean. Xi minus x bar whole square all divided by length. So now if you want to find the variance, so to find variance, what you can do, you can just simply write it as less dot variance. So that provide you the how much it is variated from the mean. So that is what variance is all about. So now if you want to perform covariance and correlation, covariance helps you to understand how much it is variated or how two variable varies together. That is what covariance is. So correlation is helping you to understand the magnitude and along with the direction. Covariance will provide only the variance or only the direction but not the magnitude. So if you want to find the correlation, you want to perform you want to divide standard deviation of covariance. So the standardized version of covariance is nothing but your correlation. Covariance will just provide you the direction but not the magnitude. So to find the magnitude of the covariance is not easy. So we use correlation by dividing by standard deviation. So let me take two variable. Let me write as x is equals to 1, 2, 3, 4, 5, 6, whereas y is equals to, you are specifying some random list of elements 10, 8, 9, 3, 2, 1. So now if I want to see the correlation between these two features, let me write it as np dot correlation coefficient COEF x, y. So I am checking the correlation, it is telling negatively correlated, negatively 93% correlated between the x and y. So now let me perform some operations to detect the outliers that is present in the data. So how do I see the outliers? For example, let me take some random data, and if you want to check the outliers, you can do it. So let me take down the data, any of the different libraries that is already present. Let me load Seaborn and load the Titanic dataset. So df or Titanic is equals to sns dot load underscore dataset Titanic. So Titanic dot add. So let me print it as 4 records. So 4 records is printed successfully. Now if I want to check the outliers for the fair amount, so where amount is having the outliers or not. First let me check the box plot, sns dot box plot of Titanic dot fair. So that prints the information. Can you see here where my data is having an outliers, x is equals to this. So the data is having an extreme outliers. So to treat the outliers, what I can do, first I want to find the first quantile, and first let me write as, let me provide an IQR method. I will go with IQR method. IQR is nothing but interquartile range. To find the IQR interquartile range, what you can do, first you want to make sure that to provide an IQR, that is Q3 minus Q1, that is what IQR stands for. IQR is equals to Q3 minus Q1. So what is your Q3? Third quartile, that is, let me write as third quartile is nothing but DF or Titanic dot quantile of 0.75. So this is your third quantile. So let me write as Q1, that is your first quartile, that is nothing but Titanic dot quantile of 0.25. So now let me write the IQR method. IQR is equals to Q3 minus Q1. So it is successfully it is telling an error. So entire Titanic I am telling Titanic dot fair. So I am taking for only one column, that is fair column. So this is successfully printed. So what IQR does in the sense, it prints the middlemost observation, middlemost 50% of the data. Now I want to calculate the lower end value and higher end value. So to calculate the lower end value, we have standardized a formula, that is Q1 minus 1.5 into IQR, and higher end value is nothing but Q3 plus 1.5 into IQR. So this is your lower end value, print lower end and print higher end value. So this is your lower end value and higher end value. So any data which is more than 65 is an outlier, and any data which is less than 26 is an outlier. So how do I check this? You can just simply write Titanic of square bracket, Titanic is greater than higher end, Titanic dot fair, right? So these are the element which is having an outlier. So we have 116 records which is having an outliers. If you want to extract only the fair amount, you can just use square bracket and you can just specify the fair year. So that is extracted only the fair amount. So that explains these many records having an outliers. If you want to find the length of it, you can just write shape, and that provides you the details. That is 116 records. So this how you can simply find the outliers, and you can treat the outliers in statistics. So this is all about descriptive statistics. So in the upcoming session, you will be understanding the various terminologies and statistics. Thank you.